So in this video, we'll look at the concept of limit goes to infinity. Let's look at the notation we have here. You see, it's really quite similar to the last couple of videos, but I'm looking at x goes to infinity now. And so what does it mean by x goes to infinity? So let's look at an example, then we can talk about that. So for example, um, if you go back to the first principle of approximation, it essentially means you can choose values that approach this point. However, infinity itself is not a number, it is a concept. The concept is that it is just so big, it's bigger than all numbers you have ever seen. So what does it mean to approach infinity? Maybe we can choose a couple of points like this. Depends on your starting point. I can actually start with maybe 100. With the next point, I can go to maybe 1,000. The next point is 10,000. So similarly, for the approximation method, we can really replace x by the value you choose to the fraction you have now, and the next one is gonna be 1 over 998. The last one is gonna be 9,998. So you see, let's think about this problem. We pay more attention to that. First, the value you choose here, every time you're adding a zero to the end of the number. So it's clear that the number of x, I mean the values you choose is jumping up quite quickly. It is increasing by 10 times the last number. And basically it is going to infinity in this case, right? Let's look at what's happening on this trend of values. This trend of values means what? If you look at the numerical answer, this one is quite close to 0.0. This one is quite close to 0.001. This one is quite close to 0.0001. And you can make a good guess. I believe that the trend, as you can see, is quite easy. It looks like it is approaching zero, right? Because you see the numerical value every time is going down. It is decreasing quite quickly, actually. And also, the fact is that there's no chance it can be negative. So it looks like it is decreasing to zero. So now we can claim that limit x goes to infinity for the fraction 1 over x minus 2 is going to be 0 because of this. The value of the function f is approaching 0 in this case. And let's think about it this way. Let's think about it this way. If you replace x by infinity, and it is something quite informal. Mathematically, it's not precise because usually we don't look at infinity. And infinity is not a point, it is not a number, it is a concept. And let's look at what's happening. Please think about it this way. This number is just huge. I mean, it's infinitely huge. We can't even describe this number by words or by writing all the numbers down. It's just huge. Minus 2, 2 is so small. 2 is so small comparing to infinity. So we can imagine that I'm really talking about, in this case, is 1 over infinity, right? And you can think of 1 over infinity as 0. The way to think is like this. The logic is 1 divided by an infinitely big number, and obviously as a fraction it's gonna be infinitely small. And you can really think of this concept as 0 as a concept, 1 divided by infinity. So as a concept, 1 divided by infinity is gonna be 0 as a concept. So let's look at more examples. So let's look at the current problem. In this problem, we are looking at the fraction 2x squared plus 7 at the top and x squared plus 1 in the bottom as the denominator. I'm taking the limit x goes to infinity. Let's check what's happening here, and I give you some hints here. The fact is that you see, this kind of constant is so small comparing to these terms. Because these terms are just big. I mean, if you replace x by infinity, x squared obviously is a huge term. It's the concept of infinity. Same thing for the top as 2x squared. It is still the concept of infinity. But 7 and 1 are so small comparing to infinity. So the fact is like this. If you have a polynomial over polynomial, and when x polynomial of x, of course. So when x goes to infinity, if we take the limit, this one, so this one actually should be approaching um, the value by looking at the simplified fraction by choosing the highest power term, highest power of the polynomial. So highest power of polynomial at the top divided by the highest power of the polynomial in the bottom. So please think about that. And what does it mean by that in this problem? When you take x go to infinity, it essentially means instead of looking at the whole big fraction, I can just focus on the highest power term for both the polynomials on the numerator and denominator. So I can just ignore 7 and 1 and just put it like this. And of course, x squared divided by x squared can be cancelled out. So it means that the answer is 2, right? So it's really quite a nice shortcut to get the answer out. Let's look at one more problem. When I take limit x goes to infinity for x plus 7 at the top divided by 10 minus 2x in the bottom. So let's check what's happening. As I said, we just have to keep the highest power term. I'm using this note. The highest power term at the top is x, the bottom is minus 2x, right? And x is cancelled. So we are getting this value. So that's really quite a nice shortcut to get the answer to such problem when x is approaching infinity and when a fraction you see is polynomial over polynomial. But we'll have a lot more to say about such limits a little bit later. So that's the end of this video.